again to the second part of this video, and in the last video we just stopped at the point where we are creating this file system instance on the object space of the heap, and I have a reference SR, which is a static reference part of the file system class that is actually pointing at this instance that has just been created on the object heap space. Okay, now what does this method do here? The method CFSI, after having instantiated the file system instance on the object heap space, is just going to return single reference. Now the question here is, who does it return back to? If I go back to my stack here, and if I look at my stack frame, I can see that the CFSI, that the create file system instance function was actually called by the constructor finder window, right? The preceding stack frame just after this happens to be finder window constructor. So single reference just contains as a value the memory address of where the instance file system has been created on the heap. That memory address gets returned back to the finder window constructor. So as the method create file system instance returns, the stack frame pops off. Okay, so this is going to get popped off. So I'm just going to remove this over here. I'm going to remove that, and the next method that is currently executing at this time is the constructor. So if I go back to the constructor of the finder window, I see that the instance reference to file system is now going to contain the same value that was returned from file system.create file system instance. So my reference over here happens to be RTFS, and this RTFS now contains the same memory address as a value, which means from this picture point of view is going to point at the same file system instance that the static reference, single reference inside the class file system is pointing at. Okay, so now I've set my reference to file system. This constructor returns, and as the constructor returns, the stack frame gets popped off. So my stack frame gets popped off, and I know this is going to get a little bit uglier because with all that erasing and redrawing, but anyways, let's just get this picture a little bit cleaner. And of course this is orange here, so let's draw this as an orange line there, and which means I'm going to come back to the main method here. And what I have here is fw1 equals to new finder window. So fw1 is containing the memory address of wherever this finder window instance happens to be on the object space of the heap here. Okay, so this is what the picture looks like. Just after finder window 1, just after this line has been executed. Now let's just look at one more line here. So let's see, finder window fw2 equals a new finder window. So it's a call to a constructor. Let's create a new stack frame over here. Okay, so this is going to be fw, that's the class, and the constructor that gets called is the finder window, and what I have now is a new instance that has been created on the heap. So somewhere on the heap you can draw a new finder window. Okay, and of course I have my reference this that is actually pointing at this. So my reference this. Okay, anytime when I use this inside my instance members, it's actually referring now to this second instance of my finder window. And what the first thing that this constructor does, it calls the method create file system instance. So a new method call meaning you need to push a new stack frame onto the stack. So I have my new stack frame which belongs to the class file system. So let's use FS for short here, and this is CFSI. And the method create file system instance, the very first thing it does, it says single reference equal to null. But now if I see my single reference, if I look at my single reference here, which is right here, right? This single reference is no longer null. It's no longer null because it is actually pointing at some place on the object heap. It does contain some memory address as a value. Because it is not null, this condition, this Boolean expression now becomes false. Because it becomes false, you never instantiate a file system instance again on the heap. On the other hand, you just return back single reference. Single reference still contains the old memory address of the file system that it had previously created, right? It just contains some memory address, and that memory address now gets returned. As it gets returned, and as a function create file system instance returns, you now remove this stack frame CFSI. It comes back to the constructor of the Finder window, and inside the constructor of the Finder window, I'm going to say reference, this piece of the code over here, reference to file system equals to whatever is the returned value. That returned value happens to be the memory address that is inside the reference SR. So what I have now is when I say reference to file system equals to that entire thing, I'm going to say inside the second instance I have RTFS that is actually now pointing at the same file system instance. Now as this constructor returns, the stack frame gets taken off, okay, and as it gets taken off, let me just be a little bit consistent with my pictures here. I'm going to have a local variable fw2 that is going to point at this Finder window. So what this memory model is actually essentially showing us over here is that because the file system happens to be using the singleton design pattern, I have only one instance of the file system initialized on the object heap space, but on the other hand, I have these multiple Finder windows that could be a Windows Explorer window, or it could be any kind of a simple UI that is pointing at the same file system. Now, one of the things that we looked at, I believe in our lecture, is that you could definitely enlarge your or add few more instance members inside your file system class, such as get a root directory, add a directory, get a list of children for a specific directory, and so and so. And as you mutate, as the instance file system mutates to add in or remove new directories and new file contents, that same it gets instantly reflected inside a different Finder window, because both of them refer to the same file system class here. Okay, so what I recommend now is for you to just do the same idea for FW3, FW4, FW5, and if you want to get make it a little bit more exciting, you can even think about when would the garbage collector kick in and remove these instances from the heap. So if I set fw1 equals to null, if I set fw3 equals to null, would that be sufficient? Would that be sufficient to have the file system instance also taken off from the object heap space by the garbage collector? So some few interesting use cases that you can play with, but I hope you find this useful as you study, and thank you.